Okay, so tonight we will learn about the key concepts and terms of machine learning. Basic ML concepts, machine learning. Machine learning is a subset of AI where algorithms learn from data to make predictions or decisions without explicit programming. So what is AI? AI is the broader field of creating intelligent machines that mimic human cognition. Machine learning provides the knowledge about the deep learning. A subfield of machine learning using neural network with multiple layers to process complex data like images and speech. Now, what is the advantage of the neural network? One major advantage of neural network is that in case of neural network, you can handle both the categorical as well as the metric data. Types of machine learning. Supervised learning, the algorithm learns from labeled data. That is diagnosing depression based on questionnaire score. Unsupervised learning, the algorithm finds patterns in unlabeled data, grouping individuals with similar stress coping style. Reinforcement learning, where learning is by trial and error, receiving rewards or penalties. AI-based mental health chatbots, adapting responses. Nowadays, we will find out different chatbots. And the chatbots, after giving you the information, are asking you whether the given content is okay for you or not. Key algorithms. Regression, linear and logistic, predicting continuous, for example, test score, or categorical diagnosis, that is anxiety versus no anxiety outcome. Decision tree, a flowchart-like model for classification and regression. Random forest, multiple decision trees combined for better accuracy. Support vector machine used for classification tasks like separating anxious versus non-anxious individuals. Support vector machine used for classification tasks like separating anxious versus non-anxious individuals. Neural network, the foundation of deep learning mimicking the brain's neuron connections. K-means clustering, an unsupervised algorithm for grouping similar data points, personality trait clustering. That means in case of the machine learning, we are giving some algorithms to the machine. And these are the algorithms usually we provide to the machine. Fourth point, data processing and feature engineering. Feature engineering, selecting and transforming data variable to improve model performance. You must have adequate knowledge about the variables or the features. Normalization and standardization, adjusting data scale for better model accuracy. Overfitting versus underfitting. Overfitting, the model memorizes training data but fails on new data. Underfitting, the model is too simple and fails to learn meaningful patterns. Model evaluation and validation. Accuracy, precision, recall. F1 score, matrices to assess ML model performance. Confusion matrix, a table showing correct versus incorrect classification. I have told you that is the classification matrix or confusion matrix is vital. Because you can identify to what extent your model is effective for the new data. Cross-validation, splitting data into training and testing sets for robust evaluation. Advanced topics in ML for psychology, natural language processing, analyzing text, for example, sentiment analysis of therapy transcripts, sentiment analysis, detecting emotion from written text, predictive modeling, forecasting behavior, for example, risk of burnout based on work patterns, and ethical AI, addressing bias, fairness, and privacy in psychological applications. So these are the 6 points you must understand them thoroughly because when you apply the machine learning, then you must be very much clear about it. This is the basic concept of machine learning. Now, students, if you have any question, you can ask me. Vishal, can you tell me why we apply normalization or standardization?
Yes. Sir, it is written here that we uh, adjust data scales for better model accuracy. I understand that um, maybe we manipulate data or adjust data in some way so that the uh, model is giving very specific information which has been asked from it, or they are predicting uh, uh, with- without much scope for error. So normalization and standardization uh, might decrease scope of error, um, improving accuracy in prediction or classification. Sir, I remember one thing that recently uh, Google, when it released Gemini, it was under very much criticism. And then Google did some research, did some work, and they released another version of Gemini, updated one, where they made it very data specific, which improved the accuracy of the Gemini model. Um, and also now, when Gemini shows results, it provides an option uh, to check the resources. So it highlights those lines which uh, which it is referring from some source. It highlights them in green, whereas the other information which it has not taken from any source, it does not highlight that. So my understanding is that uh, it is to remove the scope of error for the model.
Okay, Vishal. That means the when we are measuring the variable, the scaling properties of the variable are different. Sometimes we find the correlation between income and the intelligence. Then intelligence scaling property and income scaling properties are different. To adjust the scaling properties, we are applying the normalization or the standardization technique. Okay. Now, can anybody tell me what is the formula of standardization? Shara, can you tell me? Okay, the formula is score minus mean divided by standard deviation. This is the formula. Mr. Jana, can you tell me that is what is the meaning of cross validation? It is written clearly. The splitting data into training and testing sets for robust evaluation. Shana, can you tell me what is predictive modeling?
Sure, as far as I understand, predictive modeling is based on linear regression, where uh, with the data available of one, like if there is a strong association or relationship between two variables, we come to a point where, based on the data of one variable, we are able to predict what would happen to the other variable as well in near future. Say, for example, we have data about an individual's course on, say, their entrance exams, and we are predicting about their probable performance on their first semester exam in the upper grade of education. So, in that case, predictive modeling works.
Yeah, predictive modeling is related to the forecasting of the behavior. So in your office, you have noted the stress level of the employees, and based upon that, you can predict what will be the productivity of the company.
Sir, can I ask a question?
Sure.
Sir, regarding cross validation, I understand that the data that we split into one training
Two
set.
groups. One is training data, another one is testing data.
This. So that means that my question is, what do we validate it against? Because one is training data, so that means the model is trained on that, and it will pick some uh, raw data from testing set, and it will make a prediction, and then we will check with testing set whether it is predicting right or not. Is that how it works, sir?
Yeah, suppose you have the 100 employees
Mhm.
and you have collected data from the 75 people
Mhm.
and you develop the model.
Right.
The discriminant function, you have developed that function. And based upon that function,
Mm.
you are predicting the other person
Mhm.
out of these 25.
Yes.
Okay, the stress level or whatever the uh, variables you have taken.
Mhm.
That means whatever your model, that model is important for predicting the another group from which you have not collected the data initially.
Um, right. Understood, sir.
Okay, so this is important. Training data and the testing data.
ਹਾਂਜੀ।
Therefore, it is always better
Mm.
to collect the large number of data for developing the model.
Mm.
And data should follow the normal distribution. So this is clear to all of you, the basic concepts of machine learning.
So, so I had a doubt.
Yes, Shara, please tell me.
So when So when you said the data has to be normally distributed, when the process of normalization and standardization is happening, are we following the normal distribution curve, like standardizing in the sense we convert the raw score into say Z or uh, equivalent scale? Is that what normalization and standardization process follows?
Yeah, that is when you want to collect the data, then you have to follow the sampling in such a manner so that you can get the data who will be above average and who will be the below average. Okay. If you can follow in this manner, then your data will not be skewed. If your data is skewed, then there is a high chance for the overfitting or underfitting. Okay.
Got it, sir. Yes, sir. Thank you.
This part is important. Data should not be skewed.
So one more doubt regarding this. Uh, I've learned about the normal distribution curve only in terms of metric data, but we are also testing categorical and non-metric data, say photographs or text content. Then how does normal distribution curve work in that situation?
Okay, it's a very good question. You always keep in mind that is the more number of categories will be there. Okay. When you do not want to use the metric properties, then you have to think about the more number of categories. Because when the categories will be more, then it will be very close to the normal distribution. Okay. If there
Okay,
are
sir.
more number of categories, for that reason, we are advising the big data so that you can make maximum categories. Categories is important.
Got it, sir.
If you
Thank
use
you.
only the two categories, then there is a chance of error. If there are more number of categories, then the chance of error will be less. More number of categories are important. And more number of people will be assigned in the each category. Okay. This is important because your degrees of freedom that will be close to the normal distribution if you have the more number of categories. Why normal distribution? Because if we follow the normal distribution, then we can get the observation above the mean and below the mean. So you are able to cover all sorts of people of your population. The data will not be very much skewed. So more number of categories are important. Okay.
Yes, sir.
I think there is no other question.
No, sir.
Any more question? Okay. Whatever the answers you have written in the Google Classroom, I have given the marks. So please you check. Farah, what will be the next class?
So next class is on Saturday, sir.
Okay. Next class will be on Saturday. So today I am closing.
Yes, sir. Thank you, sir. Thank you, students.
Thank you, sir. Thank
Okay.
you, ma'am.
Thank you, sir.